All right, welcome back. We're going to go ahead and this should be a pretty short video. We're going to look at how to compute the cross product here and how we can come up with a vector that is perpendicular to a plane using a cross product in this video. And then I think I'm going to save a third video for the applications of parallelepipeds and parallelograms. So, okay, let's take a look. We've got two vectors, A and B, and we want to cross them. And there's like a formula for this that I think is very like you could memorize it, but it's going to be way more work than is necessary. There's 2 or 3 different ways that you're going to see different YouTube videos explain how to do this or different textbooks, but there's a super simple way that can be used that really has to do just with the shapes of where the elements of these vectors are. So I'm going to do this in 2 different ways for these examples here. And I really recommend you try this on the second one before watching me do it a second time. I will lay it out a slightly different way, and you can kind of decide whether you like to do this horizontally or vertically. So right now I'm doing it horizontally, where I have them stacked on top of each other. And so I'm going to, for the first component here, I'm going to ignore the first column, and I'm going to do a little x subtraction here. So this is 3 times negative 5 minus 7 times 4 for that first component. So 3 times negative 5 minus 7 times 4. And the order does very much matter because subtraction is not commutative. So then we'll look at the second component, and we will ignore the middle. And there's a couple different ways of thinking about this, but it's going to be the same. I like doing it where it's the exact same shape. And for those familiar, this is a little determinant computation. So if you have done 2 by 2 determinants, it's the same little computation. So this is 1 times negative 5 minus 2 times 4. But the middle term has an extra step of you need to negate your answer when you do this. And then we'll go to the third term, and we'll kind of just repeat this process. And here I'll ignore the third entries, and I will do 1 times 7 minus 2 times 3. And so we'll go ahead and just do that arithmetic. That's negative 15 minus 28 is minus 43. Then in the middle, I've got 1 times negative 5. Negative 5 minus 8 is negative 13, but it gets negated to become a positive 13. And the most common mistake is missing a negative in these computations. Finally, the last one, 7 minus 6, is just a 1. And we do want to try and do this, in our heads as much as possible, but without making mistakes. So it's like a little exercise in just kind of like holding that arithmetic stuff in your head. Okay, so I'm going to do part B, and I'm going to do this in a slightly different format, but it's the same exact idea. I'm going to take A and B, and I'm just going to write them vertically this time. So negative 2, 3, 5, crossed with negative 1, 0. And so to start, I'm going to ignore that first entry. And we'll do that same little determinant shape here. That 0 minus negative 5 is a positive 5. Okay, so 0 minus, but then 5 and negative 1 is a negative 5, and it's negated, so it becomes a positive 5. Then I ignore the middle. same little cross shape with a subtraction in the middle. We've got 0 minus -5 again. Becomes a +5 once again. Go. And finally, I ignore the third and do our little cross shape. Like that. So I'm going to get a +2 minus a -3, so +3. So 2 plus 3 is 5 again. So we have 5, 5, 5 in this case. Now, I want to double check always the middle. I think I may have forgotten the negation of the answer there, so let's just look at that one more time. Ignoring the middle, we've got 0 minus -5 becomes a +5, but we need to negate that middle term. So yes, we definitely need to tack on a negative there. So 5, -5, 5 as our final answer. So you could do this in this nice vertical. This, I feel like, is the most space saving. You want to try and do those computations in your head whenever possible. Use scratch paper if you need to. We don't want to be using up a bunch of space on our paper for showing this computation, right? We just want to be able to kind of do it off to the side or in our heads and be moving on. Most of the methods that you see in textbooks and on YouTube are going to end up using like a whole lot of space on your paper in order to get through. And they work, and there's nothing wrong with them. But I really like this little compact method that was shown to me by my linear algebra instructor like too long ago. I'm not going to say. So I hope that that is helpful for you. And again, feel free to go back through and rewatch those and try them on yourself. Make sure you're able to get the same answer there. Let's go ahead and see how this cross product relates to perpendicular vectors. Remember, cross product is going to output a vector that is perpendicular to both of the initial vectors. So we can use that when looking at equations of planes. And in this next section, where we're really going through equations of planes and how to construct those, it's going to be important for us to understand how that dot product is used to build up those how the cross product is used to build up those equations. Okay. So here in this problem, we want to find a vector perpendicular to the plane that passes through the points P, Q, and R, 1, 4, 6, -2, 5, -1, and R, 1, -1, 1. So I'm not really worried about where I put these points. I'm just going to say here's P, here's Q, and here's R. We could rearrange these. The concept is what I really want to get, and the math will do itself for us to get the right answer. But I draw the 3 points, and then I draw 2 vectors between these points here. And I don't have to set it up this way. I could set it up where I'm going from Q to R and Q to P, or I could do R to P and R to Q, right? But I start with one point, and I draw from that point vectors to the other points. So this becomes PQ, and this becomes PR. And PQ, from P to Q, the x component, 1 to -2, is a -3. The y component, 4 and 5, 4 to 5 is a 1. And then the z component, 6 to -1, is a -7. PR, let's make this a little easier to read here. P to R, this is 1 to 1 is 0, 4 to -1 is -5, and 6 to 1 is also -5. So I've got these 2 vectors, PQ and PR, and I want us to note that this plane goes through all of these points, right? So here's our plane, and both of the vectors PQ and PR fall within this plane. And all 3 points, P, Q, and R, are part of the plane, right? And if you think about how many points do you need to define a plane, it is 3. So if you only have 2 points, there's an infinite number of planes that go through 2 points. But as soon as you have 3 points that are not collinear, that don't fall in a straight line, there's only a single plane that can go through those 3 points. So the plane is really defined with P, Q, and R here. And we want a vector that is perpendicular to this plane. So I can draw a vector here, and I see that this vector can be, I'm not too worried about its length, just a vector that's perpendicular. I can do PQ crossed with PR will give me such a vector. So PQ crossed with PR, and go ahead and take a second and practice your cross product yourself. I'm just going to jump into it. Go ahead and pause if you want to try this on your own. PQ is -3, 1, -7. And we're going to cross with 0, -5, -5. Having a 0 in here really helps us a lot. I will ignore the first component, and we'll get a -5. Stop right here. -5 minus 35. And then if I ignore the middle, we're going to get 15 minus 0, but we want to negate that. And then if we ignore the last component, we'll get 15 minus 0 again, but we won't negate it. Just simplify that first. Now, we just want a perpendicular vector, so we might use then a shorter one. We could get a unit vector if we wanted to. So this is similar to, it's just a shorter version of, and I like making the first one positive. Let's divide everything by -5. We'll get 8, 3, -3. So we'd use that, or we could normalize that down to a unit vector so it had a length 1. I'm not going to do that here. Having just the smallest whole numbers is not a bad idea either, just for computational simplicity. Okay, so that's kind of the basics of how we compute the cross product and how it's used with equations for planes, which we'll really dive into in the next lesson. But I'll leave this video at that, and then in the next video I'm going to go into parallelograms and parallelepipeds. I really encourage everyone to say parallelepiped like 10 times fast. Super fun. Okay, see you in the next one. Bye.